Don't forget that your definitions are going to be due on Monday, the day that we take our test, and they're going to be due at the very beginning of class. You need to follow the format we've used so far this year, SUN, which means that you skip lines between, you underline your term, and that you number each one. And you can turn it in on notebook paper, you can type it up and print it out, either one. When we are trying to identify the different models of the atom that have existed throughout the years, I find it easiest to remember them in chronological order. Just start with the oldest one and make our way forward. So the oldest one is the simplest, the one that looks like a solid sphere, and that was John Dalton's model when he revived the idea of the atom in the 1800s. Not too long after that, J.J. Thomson discovered that there are negatively and positively charged particles that are dispersed throughout it. So we end up with Thomson's plum pudding model. And plum pudding, in England, pudding is just like a dessert. So plum pudding is kind of like a raisin bread, and instead of raisins scattered throughout, it's plums. And sometimes it's referred to as the plum pudding theory. After that, Rutherford performed his gold foil experiment and discovered that it's not just positives and negatives scattered all about, but you have a positive center, a nucleus, and the electrons are spread around that. So then we have Rutherford's model. Following Rutherford, instead of just saying the electrons are spread randomly about, Bohr discovered that they're going to be in orbits. So we have Bohr's planetary model, because they orbit around the center like planets around the sun. This one's a pretty easy one to pick out, because it looks just like planets. And then the last one is the one where it looks all fuzzy, kind of like bees swarming about, or it kind of looks like a target. That's because we currently know that they're not in perfect little rings, perfect orbits, like in Bohr's planetary model, but they're regions where electrons are most likely to be found. There are still different energy levels, but we can't pinpoint exactly where those electrons are going to be within that energy level. So this is called the quantum mechanical model. And later on this year, we're going to learn more about quantum mechanics and talk about this model in a little bit more depth. Okay. So identifying the scientists and their contributions to atomic theory kind of goes along with our model here. The first person who presented the idea of the atom was our Greek guy, Democritus. And then a while passed, and no one really talked about atoms all that much until the revival of the idea of the atom by John Dalton in the early 1800s. And then again, after Dalton, who said it was just a solid substance, Thomson saw that there were multi-charged things within. So discoverer of the electron was J.J. Thomson. After that, Rutherford, with his gold foil experiment, saw that there was a positive center and nucleus in our atom. So Ernest Rutherford was next. That's an R, Rutherford. One of his students/associates, James Chadwick, identified that part of that nucleus was not going to have a charge, so he first identified the neutron. And then the idea that electrons orbit like planets around our sun, that goes along with our planetary model, and that's Niels Bohr, who was not boring. Okay. Like charges, if it's positive and positive, negative and negative, those are going to repel. And then if we have opposite charges, a positive and negative, those will attract.